medical device ontologies. But this is great if you want to know a lot about cats, right? Or anything else that you'd find in large quantities on the internet. But the problem is that if you want to do something specialized, you need a lot more data than that. And that is both something that is inherently expensive. They've just come out with statistics on how much it costs to train some of these high-performing new Microsoft and Google models. But it's also not very green to spend all that energy. And most of you don't have the data anyway. I bet you everybody here doesn't have the data. For example, it took 68 million games against itself for AlphaZero to train. And there's a lot of places where this just doesn't work. For example, you really can't have your contact center simulate itself calling itself 68 million times. NLP, artificial data, is something that I don't personally believe in, and certainly in this kind of environment, it's very difficult. So what you need to solve this is transfer learning or domain adaptation. It's basically the idea that we want to take customer intents and product names and jargon and make it look like the system trained itself on the whole web full of your data rather than a whole web full of cats. I've been working on this for quite some time. Company spun out of my lab at MIT, so for people who have heard of Luminoso and wondered what it is, we do transfer learning to do domain specialization for financial services, pretty much any vertical because it's domain specialization. So financial services, we do anything connected with mobile, including mobile gaming. So if you've called either your phone's helpline or you've called the helpline of the game you play too much on your phone, you probably get our stuff. And we help do IVR, which got mentioned here, so routing, augmentation routing, as well as sort of intent understanding and figuring out what's driving KPIs one way or another. So that happened, and that's exciting. There are other ways of doing transfer learning. One of them is, of course, to pre-train the network and then train a little bit more on your specific data. If you're using certain kinds of things, you can look up a technique called fine-tuning or layer freezing, which works really well on a couple of different techniques, and there's toolkits out there for using it. If you know what GPT-2 is, there are also toolkits for fine-tuning GPT-2, and if you want to talk about fine-tuning GPT-2, I really want to talk to you at the break. If you're doing classification and you want to specialize to a particular knowledge graph, FastAI's OMFIT is really helpful and can help you do better categorization in a specific domain. And this is the question I always get asked, is for what should I download to do this for different things. So this is work that my student Pedro is doing at the Media Lab, which is the idea that when you retrofit, you're doing a very manual process. And his example is always, you can go, your knowledge graph will have the word dog in it, but it won't have the word doggo in it. And if you've spent any time on the internet, you know what a doggo is. It's a really cute dog. And so you end up retrofitting dog to the right place, but doggo stays in your model in the wrong place. And this is a problem downstream. So what you need to be able to do is teach a network to be able to recognize the behavior pattern that happens when you retrofit, and then figure out to retrofit doggo into the right place as well. So you train a network to do that, as opposed to just doing it by hand. And so this automation of this technique is something that might be interesting down the line. It's also probably deeply interesting for debiasing, but having the training data to do that requires you to have a corpus of things that are biased and things that are not biased. And if you have that, I would love to speak to you. And if you figure out how to build that using crowdsourcing, I would love to talk to you, and I'm one of the people who started crowdsourcing. So it would be a very interesting question to how to do that. There's all kinds of weird structure in these networks. So if you're interested in the geometries that are inside the BERT and Elmo and GPT-2 type networks, it's really fascinating and cool. And we don't know what it means yet. You know, people have seen, there's a great paper out of Stanford where people are talking about whether or not artifacts they've seen represent syntax inside of BERT and Elmo. And there's a really good paper that came out a couple of weeks ago on the geometry of BERT. And if you're interested in that topic, that's a great place to start. But to sort of bring us back here, you know, the problem that I was talking about with the way we interact with machines, that's happening again, right? So, you know, when we communicate with an agent today, it doesn't really communicate with us. It's kind of like talking to a robot. And for the most part, that's not what people want. And it's also not something that works for every environment. It works in a very specific place. So chatbots tend to really succeed when you end up in a situation. So a chatbot works essentially by figuring out people's intents or goals, much like we talked about in search earlier, and then figuring out how to get that person to that goal as fast as possible. And that's because CX is the best place to start a company for AI, because it's KPI driven and because people buy in that area. So everybody has started developing technology for CX, where both you and the customer are aligned in the idea that it's goal-based, right? You find out your goal and you get the customer there as soon as possible, and then everybody is happy. None of you want to be on the phone with your cable company for a long time, and the cable company doesn't want you to be on the phone, so everybody's goal is the same here. Where these things tend to fall down is in places where that isn't true. In places that are more about a conversation or an engagement or a story. And one of the reasons is emotion, of course. We're always very emotional with our computers. We want them to respond to us, and we spend a lot of time thinking about what would happen if they did. We spend a lot of time drawing or making art about it. You know, it's one of those things where the idea of being able to communicate more naturally with a machine is super important. And that's because emotion is really critical to communication. Emotion is, you know, we've seen that building systems only in English definitely has an effect on the way people speak languages, right? It was found, New York Times published, and a couple of people have found that in Iceland, people speak less Icelandic now, since their phones didn't work in Icelandic. And so people would talk to their phone in English, and then they'd start talking to each other in English, and now fewer people speak Icelandic. I'm a computational linguist by training, which means that I think this is bad, right? I would like people to communicate in a wide variety of different beautiful human languages, and I think that means we need to think about that. But to go back to sort of chatbots and goals, right? Well, we can think a little bit about this as being recorded, so I might get in trouble here. There's a case study of a large retailer, large tech company here, working with North Face as a retailer on putting a chatbot, and this is on their website, into a retail environment. And you can talk to this chatbot and it will help you buy a coat. And what this did for North Face was it increased engagement, which is a KPI based on how long the chatbot people stay on the website. So this is not actually what retailers want. Retailers want to increase conversion, which is the KPI that means you actually bought it, or click through sometimes, which is the KPI meaning you clicked on it to look at it. Right? Engagement gets you more money if you're a retailer, only if you're Target or Walmart or somewhere where you know these retailers, you can think about them. You walk into the retailer and you buy like 5 things you didn't mean to. The digital equivalent of that is where engagement is a good KPI. Everything else, if you're going to buy a coat, you're not going to buy more coats because you spent more time on the coat store, right? You only need 1 coat. Well, maybe you need more than that, but you're probably only buying 1 coat at any given time. And so we need something that's a little bit more personalized to this type of goal. And one of the other places you see this all the time is entertainment, which is fascinating, right? So in entertainment, you end up listening to studios and to people who are trying to say, how can we help the next generation build more interactive experiences, right? So they talk about this dichotomy between mass production and personalization. And the interesting thing about that is they feel like these things are in opposition and that you'll never be able to personalize entertainment experiences at scale. And we started thinking about that at my research group maybe about 1.5 years ago at MIT, where I basically came back to do computational creativity. And one of the reasons I did that is because before I left to found Luminoso, we started doing a project on what was supposed to be a project on multimodal learning. And one of those things about the Media Lab that's really quite fascinating is that we work with companies, and those companies like to have actual demos. So the unofficial model of the Media Lab is, again, I'm going to get in trouble for saying this on the record, is demo or die, although it's now deploy or die, so everybody makes demos. And so we built this wonderful tool where you could tell a story. We built a model of the system of the way people represent color and the way people think about color. We took data from the webcomic artist XKCD, who did a survey about this, and we built a model, an embeddings model, and we aligned it with a language model. And then we built a system where storytellers, like if you've ever seen NPR's The Moth, wore a headset and then spoke about, told a story. And very quickly the storytellers realized that they were collaborating with the machine as much as they were collaborating with the audience. Normally when you tell a story in a professional context, you kind of change the story based on people's reactions. They were also changing the story based on the computer's reactions, which was really interesting. So we came back to try to build digital characters that could withstand the same kind of. We also got very interested in what would happen if you had a bunch of different agents working together and talking to each other. And we're working on a project right now with a student of mine, Nina Perez, who is trying to get agents that represent the media personalities of different parts of Mexico to have conversations with each other. So we're trying to figure out how can we design for different types of interactions. One of the fun ones here is that conversation is planning. So why does everything sit in the chatbot? Why is there not a planning system that's completely separate from the generation system? Why do we think that one system has to do all the conversation? And that's something that's starting to gain a little bit of traction, and we're very convinced about this. So we're very excited about this. And we also need a system that can get more sophisticated as users get more sophisticated. Like, I'm gonna be honest, we're talking about entertainment agents here, right? Which means that we're doing a little bit, we're not gonna build a real digital person. We're doing entertainment industry smoke and mirrors, right? We're thinking about what happens in a narrative, how do you walk through a narrative beat, what makes you go from one beat to another in a way that tells a compelling story. And often people present themselves as characters as well, so it's less realistic conversation in some sense. And the goal here is really to say, with all of this work, is really to say, how can we find a way to communicate with machines the next time that there's a breakthrough and we have a new way to communicate with machines? How can we communicate with them in the same way that we want to, in a much more natural way, rather than going back and learning how to search or talk to Siri the way we used to? How about we figure out a way to talk to machines the way we really want to? So the new company is called Belang that's working on this, and we're also working on the much more digital character, sort of theme parky future of VR version of this at the Media Lab as well. Whenever you're doing any of this, I want to quickly say, always think about what you're doing. Like if I'm building a digital character, I don't want to take that. It's in big companies as well. It's used actually in a lot of different places, so it's not really going to go down on you. And we continue to put out new versions, and we talk about that online. And my collaborator Robin Spear does a lot of work in bias and AI and in new ways of understanding and doing transfer learning for industry as well. And she's fantastic at that. And she also writes a really entertaining blog. And lastly, I can't talk about ConceptNet turning 20 without saying thank you to all of the crowds that have helped with the crowdsourcing over the years part of ConceptNet. Like thousands of people entered data into a machine when they were bored in the evenings or during class was often when people said they did it. And I cannot be more grateful because the data we collected, we could not collect today, and I don't think we could have collected any other way. So I think everybody who helped out with this project in any way, shape, or form over the years, there are a lot of them, really deserve a round of applause. So thank you guys. Hopefully some of that was helpful. I'm happy to deep dive on anything I walked through, ranging from sort of the much more mathy stuff to sort of the high level conceptual stuff. And I think I'll take some questions now. Okay, where are you? Sorry.
Have you recognized any alternatives to the dialect problem within STT and NLP other than additional training?
Additional training. Sorry. I mean, this is a fantastic and interesting problem, and with their dialogue is also anything that's code switching or typing, romanizing, inconsistent romanization. All of these problems I wish were solved, but no, I need more data, really, from what I know. But this is not my deep area. So,
thank you.
Great, awesome. Let's give it up for Dr. Okay, great. So drinks are being served in the corner over here, and then pizza should be coming out very shortly. We'll take a quick break so everyone can eat and.